So let's look a bit at the kind of different Falloffs or nodes that we can use, basically the tool set that we can use to work within the Falloff system. So what I've got here is I've just got a plane that is driven by a cluster that's just moving 2 units up in Y. So let's go in and just do what we've done before. So we go in and we go on our cluster, our input attributes. We'll go and right click on Falloff and we'll assign our primitive Falloff here. And we can now see that, cool, all of that is working kind of as expected as we would do here. Yeah, that's all looking very nice. So let's go and look at what the assign uniform Falloff is. So as soon as I add that in, all of our deformation goes away. And now I'm still selected on the kind of primitive Falloff here. So what gives? So let's go back to our cluster. And we can see that under a Falloff, we now have the uniform Falloff actually assigned. And what I can do is I can right click and select Falloff. And you can now see that we get our Falloff. Now, the thing about the uniform Falloff is that it's not really a transform, and that's why it's not showing up in the outliner. It's basically just like a flood weight. It will just apply the value that you set in uniform weight to everything. So you can see as I'm kind of changing this value, it's just adding that into that kind of weighting there. So if I set that to 1, that just kind of pushes it all up there. So this is just really useful if you need to just flood a certain value to something, or if you want to be able to control a value, you could use this to kind of like offset like a Falloff system that you have. So let's just kind of keep going as well. Now the next one is the blend Falloff, but we'll kind of skip over that for now and we'll look at the component Falloff for now. Cool, so you can see if we now go and we'll select the component Falloff, there's not really too much kind of happening in here now. So I'll just go back to the cluster, because what the point of the component Falloff is sort of a bit against everything in the kind of primitive and uniform Falloff, in the fact that it's actually working directly on like the components. So what we can do is we can actually go down to ping component Falloff and we can go to component Falloff. If I select this, now you can see that we have our kind of normal paintbrush, but we have our component Falloff. So if I go in now and I just start kind of painting around here, you can see that we're now painting just as if we're painting the normal kind of cluster weights. But I just want to make sure if we go into paint cluster, you can see that our weighting is still fully at 1. We're only painting on this one thing that's in the Falloff system. And that's what's really powerful about it, is that we now have these weights that we would sort of normally paint directly on the deformer, but they're in this procedural system that we can go in, we can start to manipulate them a bit more. And because now we've gone in and we've kind of done exactly what we've done before. So like I said, why is this nice to have in a procedural system? Well, because now we can go and we can go here, right click, and we can do assign blend Falloff. So if I now do create blend Falloff, nothing really happened, except you can see under Falloff, there's now a blend Falloff added here. So if we right click, we can go select Falloff and we're in here now. And you can basically see that we have the component Falloff is now added in here. So one thing to kind of note here as well is that the base weight is pretty much the same as adding a uniform Falloff. It's basically setting the kind of default weight for the whole system here. So if you didn't have a kind of component Falloff in here, or basically if the input from the component Falloff was 0, you would still have 1 here, depending on, of course, the kind of mode that you have here. But by default here now, this is set to multiply. So because our component Falloff has these kind of values painted in here, and so basically in here, it's 0, black, and here it's 1, white, and basically multiplying those two values together will still give us exactly the same as we had before. But I can still go in here and I can actually change this now. And you can see that as I'm changing this, it's multiplying or basically pushing on the parts that we painted white. You can see I can basically go backwards and forwards on this. So that's something to just be aware of, because this has tripped me up a couple of times where I've forgotten to kind of like add this in, or like keep that in mind when I'm doing my kind of operations here. So let's go and add in a couple of more kind of Falloffs here. So you can either do the plus sign here, and I'll just make a new row, and then you can right click and assign any Falloff, or you can just right click directly and you will still get the same kind of menu. So I'll take our primitive Falloff in here, and now everything suddenly went away except like these little peaks that are inside of this. And this actually makes sense if you think about it, because the modes here by default, they're set to multiply. So really everything outside of the sphere is 0. So everything inside the sphere, or like fading in here, is 1. So basically what's happening is that we're multiplying, this base weight along with the component Falloff together to get the painted weights that we had. And then we take those painted weights and we multiply them against the primitive Falloff. And that basically allows us to kind of show, or like move up the, kind of like expose the deformation, or like the painting that we already had here. So you can see how this can be very powerful in kind of mixing this procedural approach with this painted approach, where you can actually go in and you can have some if you need to have some kind of like detailed painting, you can have that, but you can still expose it or like show it with your kind of procedural thing here. Or you could even just go in and say add, and what we're doing now is you just take everything that you had from before, and we're just adding the value from this kind of Falloff to it. So you kind of get like this cool kind of bulging effect, like something sliding underneath the surface or kind of pushing along it. So there's a couple of different operations here then that I would just recommend that you can kind of play with. But multiply, add, and subtract, I think, are some of the kind of most typical ones. So you can see with this we get like a bit of like a fake kind of push down effect here as well, just because of like how the cluster is operating here. So that's all cool and good here now, but let's add in just like one more here, just to kind of make it a bit interesting. So because this is really important to understand with this whole kind of setup, is the fact of like layering all of these together, especially these kind of volumes here. Because if you start doing kind of skinning, or like doing like the proximity wrap with these bindings, you have to start kind of defining areas where you want these different volumes to act. And just using the normal kind of spheres or the planes might not be enough. So you have to start kind of layering these together to kind of carve it a bit more here. So what I'm going to do is I'm going to change this to a plane, and because now we can actually do, and we can go in and do something like really nice here with just going in here and kind of fading this off as well. So we can still have all of these kind of working together and just really allowing us to kind of show, or just kind of control this deformation here a lot a lot nicer, and giving us a lot of really control over what's going on here. So let's look a bit at the kind of last one here that I haven't talked about, which is the transfer Falloff. And to do that, what I'm going to do is I'll first off create a new polyplane, which I'll make the same size as the kind of previous one. But it'll have a lot fewer kind of polygons here. So I'm going to just kind of scale, freeze here, delete history. And then as soon as we have that, I will add just a cluster to it. And I'm going to move that up to NY as well. So you can see we basically should be getting the same deformation here now. So first off, let's just try and go and add into the cluster. Let's just try and assign the blend Falloff that we have. And, that's cool. It kind of works straight out of the box here, but not really. Because if we just look through here, we're actually missing all of that kind of painted detail that we have in here. So you can see that all of these kind of primitive Falloffs, all of these kind of procedural weighting, they're just going through perfectly. But where we've actually gone in and we painted per vertex data, like per component data, that's not flowing through correctly here. So we have to go in and kind of fix that. So if I go in and I create here now instead, if I just say assign transfer Falloff, now it will do that, but I'm not really sure how this, wait, what did let me just double check here now. Did that make it? Wait, let me just see here. Ah, yes, it did. Sorry, it didn't really show up here. So you can see that we now have a transfer Falloff going into our cluster too. But, really, it's not getting anything in here. So I'm not really sure if this is supposed to be exposed nicely in the UI and I'm just kind of missing something. I might have overlooked some documentation. But basically how I've approached this is that I've just kind of done it manually. So what I'll do is I'll just go here and I'll grab basically the kind of system that we had here before. And we don't really need this, don't really need any of these. So let's just kind of clean this up a bit. And really what we want to do is we want to make sure that we can transfer all of this data onto this cluster. So what I'm going to do is I'll just take this, the transfer Falloff, I'll add that in here. And first off, let's just try and see, if we connect through here, that's basically doing the same thing as when we just assigned it. So you can go in and very easily manipulate all of these kind of connections in the node editor as well. And that's honestly most of the stuff that I've been doing, because it's a very nicely designed system that just allows you to go in and start messing about with these connections very easily. So let's see what the kind of transfer Falloff actually wants here. So it wants a weight function. So let's give it that. And it also wants a weighted geometry. So let's just give it, what I would expect would be kind of our org shape here. So let's try and just add that in here. And cool, so that's now working, but we're still missing this original detail. So what gives? Why does this still keep happening here? So one of the things as well is, I'm not sure if I always need to do this, but I've gone into the habit of always making sure that if I have a component Falloff, I will add in the, do I have that here? The geometry, the org shape of that geometry that it's on. So I'll take the plane shape 1 org here, and I will add that in so that we will have this added to our component Falloff here. Cool, so that's still not really doing anything, but at least we have that added in now. So let's kind of reconsider what we're doing here a bit. So really what's happening is that it's the output weights that's coming from this one into this whole network that's kind of messing up. Like all of this is totally fine, but it's sort of this one. So let's try and just kind of reorganize these nodes here a bit. So what if, let's just get rid of these. And what if we just take this component Falloff directly and we try and just remap this, and let's just do that right back into the kind of network that we have here. So what if we do that? That's not really giving us anything now. That's completely broken it. Well, here's one of the things now, because we've kind of reordered this, and like it doesn't really make sense to do this now, because actually the geometry that has all of this weighting information that the node needs to know about is actually the original one here. So if I go in and do that, and I'm not outputting this here. Sorry, I forgot to kind of connect that up here. I'll add that into the wait function, and boom. You can now see that, let's just go back here. Yeah, so just to kind of demonstrate that, you can see when we have this kind of transfer Falloff here, if we're using this plane shape org, which is basically this, you can actually see that even for the kind of main geometry that we already had this component on, we've kind of removed that now. But if we take this plane shape org here, we pass that in, now we're actually kind of transferring all of these values here correctly. And you can see that we get the kind of dips that we had painted on this kind of low resolution geometry as well. And all of our kind of movements here is still working. I can still go around and kind of do these. And if I go back in and let me do here, and if I do multiply instead, we still have all of the things that we had here before, but we now have it on two completely different meshes, on two completely different deformers as well. So just because this is now feeding into another cluster doesn't mean that that's something magical with the cluster. There's a couple of deformers that are supporting this. So if you're not seeing this kind of input attributes kind of show up, I think it basically will mean that the deformer that you're looking at won't be supported. Okay, so we've kind of covered most of these different things here now, and I think that's pretty much it. So hopefully this shows you a bit of how you can start to layer different deformers together and kind of think about these kind of procedural ways of doing things. And it's a really powerful system. It's one of these things where I think it looks very awkward and cumbersome when you first look at it, but as soon as you have it already set up, and you really only need to do it kind of once, hopefully, if you do it in a nice way, I think, and then it just kind of works. So yeah, I hope that kind of helps you along on the way here a bit. See ya.